We live now?
Yes.
Hey, everyone. Welcome. Good morning, good afternoon, good evening. Wherever you're joining us from all over the world, you're welcome. This is the second webinar this year by the International Occupational Hygiene Association, IOHA, and you are most welcome. We'll just give like 30 seconds for folks joining before we make a start. I see we're 95 on the call already, which is great. Thanks for signing up. Thanks for joining. I know it's going to be a very productive session, and we've got two great speakers with us. I'll be introducing them shortly. I'll just wait for more people to come in, and in 30 seconds, we will start. If you want to say your name and where you're joining from on the chat room, you're welcome to do that. We found that in some of these webinars, people that have seen each other or heard from each other in a bit can just find each other on the call and connect. So feel free to do that. You can put your name and where you're joining from. Thank you. And we had a lot of people register, over 300 plus. So I really ideally want to see us climb up to 150 before I make a start, but I'll see what happens in the next few seconds. We're currently 110, and thanks again for joining. Okay. All right. Okay, we'll make a start now. So thank you very much for joining. This is the second IOHA webinar for the year 2025. And today we'll be taking a look at new horizons in hearing safety, and we'll be exploring the future of hearing protector fit testing. Today is April 23rd, 2025. Just before I go into the webinar proper, I'd like to do a bit of introduction of IOHA. Today, I have the privilege of hosting you. My name is Matthew Olota. I'm the current president-elect of IOHA. So I'll be facilitating this conversation today. Okay. So a bit about IOHA. For some of folks on the call that may not know too much about IOHA, IOHA is the International Occupational Hygiene Association, and it is the association for all occupational hygiene associations across the world. Currently, we've got 43 member organizations as part of IOHA. The vision of IOHA is IOHA wants to represent the global community of industrial hygienists, one team, one goal. And our mission is to improve, promote, develop occupational hygiene worldwide through its members and to promote and maintain a safe and healthy working environment for all. A bit about the objective of IOHA. Our number one, to improve, promote, and develop the professional practice of occupational hygiene, to improve and protect worker health and well-being throughout the world, to promote the exchange of information about occupational hygiene among organizations and individuals internationally, to improve the caliber of professionals of occupational hygiene internationally by promoting and coordinating vocational training and by encouraging the further development of and seeking to promote the status of occupational hygiene as a profession throughout the world, to advance and maintain high level of professional competence through recognition of national accreditation schemes.
Sir, we've lost your audio.
You did. When did you lose me? I'm sorry.
That was about 30 seconds back.
Did you hear me talk about IOHA?
I think you mentioned the national accreditation schemes.
Okay, no, that's fine. I think I can go on from here. So sorry about that. To continue, IOHA also seeks to collaborate and cooperate with other societies, national and international organizations in the promotion of occupational hygiene for the protection of the workforce. Also to provide an international voice of occupational hygiene profession through the recognition to her recognition as an NGO by the ILO and the WHO. And also we seek to promote and maintain a high standard of ethics in the practice of occupational hygiene internationally. And one of the objectives is exactly what we're doing now, promoting the science, promoting a conversation like this that enables the protection of our workforce everywhere across the world through this webinar. Okay, just a quick intro to the executive of IOHA. We have our president, current president, Nancy Wilk. She's representing the ACGIH on the IOHA board, and she's the current president. As I mentioned earlier, I'm your host today, the president-elect, and I'm representing AIHN, the Association of Industrial Hygienists in Nigeria. We've got Samantha Cornell, our past president, representing the Swiss Society, and Andrew Winks, representing the Dutch Occupational Hygiene Society. So that's a little brief. You can read more or ask questions about IOHA. You can find out more on our website. So moving on quickly, some housekeeping items today. This webinar is being recorded, so you can, everyone is aware. There will be question and answer, so you can put in questions as we go on. And there's a poll function. If there's an icon, you see question and answer. And as the question and answers rolls up, if you like a particular question, you can vote it, and we'll use that poll to take the questions in the right order. You're all muted, but when it's time for questions, when it's time for questions, you will be unmuted if you need to speak. Just a note, this webinar is only open to members of IOHA. So if you are here and you're not a member, please we request that you would sign off. And by member, I mean you are a member of an IOHA member organization. All right, quickly, I'm going to be introducing our speakers, Andrew and Alison. I hope your videos are on now. So I'll take them in no particular order, but I'll start with Andrew. Dr. Andrew Meckley is an experienced occupational and clinical audiologist with a background in hearing health and educational services globally. Andy holds a Doctor of Audiology from Central Michigan University and certifications from the American Speech Language Hearing Association and the Council for Accreditation of Occupational Hearing Conservation. Andrew is a certified course director and a professional supervisor with 25 years experience in training hearing health technicians and professionals worldwide. I move on to introduce Alison. Alison Reid is an occupational hygienist and engineer who served in the U.S. Army for over 15 years. She is currently a contractor with Z-Corp Business Solutions, supporting the Defense Health Agency Hearing Center of Excellence as its occupational health specialist. Hallie holds a Bachelor of Science in Industrial Engineering, graduate certificate in Public Health and Applied Statistics, and a Master's of Engineering in System Engineering. Our professional association includes the American Industrial Hygiene Association, AIHA, the National Hearing Conservation Association, which is also a registered sanitarian with the National Environmental Health Association. Please join me in welcoming our very experienced and passionate speakers. And we would take Andrew first, and I think Ali will come in at the stage and they'll wrap it up. So I'll leave them to do their thing. So I'm going to put it on my screen. So have a great time, everyone. Thank you. Andy, you can now share.
Sorry, Andy, you're
All right,
muted.
there we go.
Muted. There
Can you hear
go.
me now? Yeah, I
Yes,
we
forgot
thanks.
to unmute my microphone. Ali and I are super excited to be with you today, whatever time it might be, morning, afternoon, or evening for you, but excited to talk about hearing protector fit testing. I just wanted to mention a little bit about the Council for Accreditation in Occupational Hearing Conservation, because that council has a partnership with IOHA, and I think this is one of our first opportunities to share information with the International Occupational Hygiene Association. So we're very happy for this invitation. Just some standard disclaimers that, the views that are expressed in this presentation are ours. They don't necessarily represent the official policy of the Council for Accreditation in Occupational Hearing Conservation, the Defense Health Agency, which both Ali and I work with. We're both Z-Corps contractors. It doesn't represent the Department of Defense or the U.S. government. The information that we are going to provide today is for educational purposes only, and any references to specific commercial products that we will certainly show some commercial products during the presentation, but the products, the processes, any services by trade name or trademark manufacturer do not constitute or imply endorsement of those products by CAOC, the Department of Defense, or the Defense Health Agency's Hearing Center of Excellence. So here are our learning objectives today. By the end of this workshop or webinar, we want you to be able to discuss the prevalence of work-related hearing loss in the United States and globally. We want you to be able to describe the importance of an effective hearing conservation program, discuss the newly published recommendations on hearing protector fit testing from the National Institute for Occupational Safety and Health, describe the training curriculum that individuals conducting hearing protector fit testing will be able to take, that is being developed by the Council for Accreditation in Occupational Hearing Conservation, identify primary methods of hearing protector fit testing, and discuss the challenges and the opportunities for implementing hearing protector fit testing in your hearing conservation program. So hearing loss in the United States, it's a real issue. There are roughly 40 million US adults in the age between 20 and 69 that have noise-induced hearing loss. And not all of them have noisy jobs. They have both, some have noisy jobs, some have noisy recreational activities. But more than 1 in 2 US adults with hearing damage don't have noisy jobs. And you can see some statistics on different noise hazards that are common in the environment. And some of these are very, very noisy, especially looking at sporting events, rock concerts, sirens. Now, I don't know anybody that has a hobby of dealing with sirens, but certainly going to rock concerts, bars and pubs with live bands can be very, very noisy. Again, more statistics related to hearing loss, but it's very, very costly. So what we're seeing in the United States through the National Health and Nutrition Examination Survey is that 1 in 4 adults who report excellent to good hearing already have hearing loss. People may have impairment in the higher pitches although they perceive normal hearing. So, they hear just fine. They just don't understand what people are saying. I hear that all the time in the clinic. I can hear just fine. I just have trouble understanding people, especially in difficult listening backgrounds. Many of these people are on the road to severe hearing impairment, but just are not aware of it. Plus, much of this can be prevented through the use of hearing protection. And hearing protection, fortunately, is being used more often. I mean, you can see it in the communities, folks out taking care of their lawn or operating equipment. They're more inclined today to wear hearing protection than in the past. But still, it's not everybody. And this survey shows that about 70% of people exposed to loud noise hardly ever or seldom wear hearing protection. Again, more statistics for you to look at. So, third most common chronic physical condition among adults after hypertension and arthritis. 12% of the working population has hearing difficulty. 24% of the hearing difficulty among workers is caused by occupational noise exposures. And then 8% of the working population experience that ringing in their ears, the tinnitus. So these worldwide statistics show how prevalent hearing loss is. I'll just pause. I'm not going to read the slide necessarily to you. But note that the numbers of young people at risk because of recreational noise, that's a big problem, not just in the United States, but globally. We have a lot of noise hazardous recreational activities. This map shows the current and the projected number of people with hearing loss in different regions of the world. And projections show that the number of people with disabling hearing loss will increase across all regions, which creates a big burden on both economically and in the personal sense. So many countries keep statistics on their hearing impairment. You can see here we have some information from the European Union, Canada, Australia, Asia, and then worldwide. And this is not all inclusive, but some that I was able to pull up for this presentation. But it's a global problem for sure. So there are a lot of US workers exposed to hazardous noise, and sadly about 1/3 don't wear hearing protection. Now, what do we mean by material hearing impairment here? Material hearing impairment refers to the 1998 NIOSH definition of hearing loss as an average overall hearing threshold of at least 25 decibel averaged over 1, 2, 3, and 4,000 hertz in both ears. At this level of hearing loss, there is some effect on the individual's ability to understand speech. So here are the number of cases of recordable hearing loss through 2015 as reported by the United States Bureau of Labor and Statistics. Now, why do you think that this is trending downward? It could be underreporting. It is an issue in approved in it. Well, it is an issue. Nobody wants to record injuries, but my hope is that it's a reflection of improved hearing conservation programs across the nation. And then another possible reason is that noise hazardous jobs are being exported out of the United States and into other countries. And so they're not being reflected in these numbers. Now, I hope that's not the case, but again, I'm holding out hope that it's better hearing conservation programs. So increasingly, it is evident that besides noise, chemicals can also cause hearing loss. And there is an international ototoxicity working group that is looking at the known ototoxicants and other chemicals that are found in the workplace that are known to cause hearing impairment or affect the ear in one way or another. But around 22 million workers in the United States are exposed to hazardous noise. And then an additional 10 million workers are exposed to solvents and other ototoxicants that can also affect hearing. So haven't government regulations eliminated occupational noise-induced hearing loss? I mean, almost every federal agency has a hearing conservation program. Countries throughout the world have hearing conservation program regulations. But remember that governments have to deal with business and may want to implement best practices in occupational hearing conservation, but because of the impact on industry and production, they may have to negotiate what they can implement and what they can implement and what is not possible to implement and still maintain manufacturing. So federal regulations don't always reflect best practices. If best practices want to be followed, so we have in the United States our National Institute for Occupational Safety and Health, and their whole purpose is to conduct research into occupational hazards and provide recommendations to governments or to organizations to on what is a recommended practice. And then the governments or organizations can either adopt those as the standard or adopt something similar. But what I want to really point out is that government regulation doesn't necessarily reflect recommended or best practice. So let's talk a little bit about the regulatory model and different models for caring for those with hearing loss or implementing hearing conservation programs. Traditionally, efforts at prevention start at the top here with measuring exposure, in this case, noise. So the primary effort should always then go toward reducing that exposure through engineering and or administrative controls and hearing protection. Since you don't always have assurance that noise reduction efforts are working, noise exposed individuals require audiometric testing to try and identify if any damage is occurring. Although, teaching and motivating is next on the circle, I'm sure that this section could probably be anywhere or even closer to the top. Record keeping is always obvious to medical people such as yourselves when it comes to hearing testing. However, the regulatory agencies expect records to be kept for all aspects of the program described on this wheel: noise control, monitoring audiometry, etc. An essential part of the hearing conservation program is to continually analyze the effectiveness of the program through data concerning all aspects of the hearing conservation program, and then taking action to improve those programs. One of those areas, it will be hearing protection, and we're going to talk about why hearing protector fit testing is so important. Now, this is a model that you may be familiar with. This is the occupational health model. As medical professionals, we always should strive to reduce the initial occurrence of any hearing loss through the prevention of noise through engineering controls or administrative controls. That's primary prevention. In practice, we have limited tools to do this, and often must rely on engineering and safety, and you industrial hygiene or occupational hygienists to take the lead on that effort. This is where individual hearing protection fit testing falls. So tools are now so widely available and easy to implement in the work environment that the National Institute for Occupational Safety and Health changed their position on individual hearing protector fit testing from a nice to consider to a recommendation. The audiometric monitoring we do is clearly secondary prevention. We are trying to identify subtle changes or trends in audiometric thresholds so we can take action to prevent further damage, often relying on the primary preventers, such as yourselves, to make those changes. Tertiary prevention is an attempt to mitigate damage that's already done. Okay, the regulatory model incorporates thresholds like a standard threshold shift to require action to be taken if this occurs. If excessive damage to hearing has been done, medical management, for example, hearing aids or other assistive listening devices, or medical restrictions from noise exposure might be in order. We should always strive to focus on the primary prevention. And this is why NIOSH's recommended calling on the program, or NIOSH, this is why NIOSH recommended calling the program a hearing loss prevention program and not just a hearing conservation program. So we'll move on now and talk hearing protector fit testing. So I'm going to turn the time over to Allie to take the lead.
But if we have a video that we produced. Sorry, I should start by saying thank you to IOHA for having us here to be able to present today. I'm very excited to be here as a member of AIHA and to be able to speak with our international colleagues. And this morning, right now that we're shifting into hearing protector fit testing, we'd like to show you a video that we've produced at the Hearing Center of Excellence within the Department of Defense for the United States, where we have recently conducted a change to our instructions, our regulations, to incorporate hearing protector fit testing into our hearing conservation programs. So we'll start with a video that we've recently produced that explains the importance of this for all those that may be going through this new HPFT requirement.
Hearing loss can have a significant effect on readiness and job performance. It is vital that your hearing protection fit correctly on and off the battlefield to help prevent noise-induced damage to your hearing. For workers exposed to hazardous noise, it is the most important piece of safety equipment. To address this issue and better protect service members and civilian personnel, recent updates to the Department of Defense Hearing Conservation Regulation now require hearing protector fit testing for all at-risk personnel. Hearing protector fit testing is an effective way to determine if your hearing protection fits properly. It provides a personal attenuation rating, which shows whether you are adequately protected.
It's specific to that individual, and the number gives them an idea of how much noise reduction they're actually getting with the earplugs, and if the hearing protection is fitting correctly.
Testing can be done when you're starting an extremely noise hazardous job, operating loud weapon systems, preparing for deployment, or during your annual exam. To protect DoD workers against noise-induced hearing loss, it is critical to conduct hearing protector fit testing. Talk with your local audiologist, hearing conservation, occupational health, or safety program managers to learn more.
So, Allie, you said there were a lot of chats that the video was echoey and it's stuttered. So, if you want to go back and look at the video, the link is what is in this part of the presentation, and you'll have access to the slides.
And I just went ahead and put the link directly in the chat as well. It's although this is a Department of Defense video, of course, it's on an open source document, as we would say, or open source video. And we apologize for that. We were testing out the audio before this, and I know we muted I muted my mics, but I apologize for that echo. But we can go ahead and move into the importance of HPFT. So we'll go on to the next slide here. So why is hearing loss such an important topic? And I know that our colleagues on this video understand the importance of hearing protection and hearing loss. And that video, of course, because we work for the Department of Defense for the United States, is very military focused, but we all know that this is not just an issue to be addressed in the military. As we've already discussed previous in the presentation from my colleague, Dr. Merkley, hearing loss is occurring in industry across the world, and the impact of hearing loss is widespread. So you can see here on the slide, hearing impairment introduces danger to the affected individual and to those that they work with. Many studies have shown that hearing loss causes communication issues that can ultimately lead to poor work performance, misunderstanding communication, repeated requests to clarify communication, hesitation in decision-making, and ultimately limited career opportunities. This can lead to significant stress in the workplace, leading to higher incidence of aggression, even in the workplace, and we do see that. And even though we may be in the fields of occupational hygiene or safety, that is still a very vital component to the overall worker health, which then contributes to productivity in the workplace. And of course, when this hearing loss is brought into our homes, hearing impairment leads not only to miscommunication, but also isolation and stress. Imagining that you have hearing loss that's induced from work, and now maybe you have a spouse and a child, or just even pets that you love to at your home, and now you can't hear them as well, right? So that's going to contribute to a lower quality of life, and potentially even, as we've seen in some studies, cognitive decline. We've also seen in a study out of Vanderbilt, which is in Tennessee in the United States, that there is a significant component of those with hearing loss also having a significant amount of fatigue, whether or not they have some sort of assistance with their hearing. So including having a cochlear implant, for example, or having hearing aids. Even when they have that assistance to overcome potentially their hearing loss, they have a significantly higher reported incidence of fatigue, which of course, as we know, fatigue is a huge factor in workplace accidents. So there are so many components of hearing loss that can affect our occupational readiness and our ability to conduct our jobs in a safe manner. It's important that employers and employees do all they can for good hearing health. And of course, we know also that while in the in how we implement workplace controls, PPE is typically at the top, or sorry, personal protective equipment is going to be at the top of that, meaning that that's the last thing that we should necessarily go to. Many times in a noisy workplace, that becomes one of the first things that we have to do. So hearing protector fit testing then becomes vitally important, because as much as we try to implement those other engineering controls and policy controls and things of that nature, we still often need to use some sort of personal protective equipment, and therefore have to ensure that the worker is safely using it. So what exactly is hearing protector fit testing? So I don't typically read from slides, but I think that the slide here is very well put together in terms of describing exactly what HPFT, or hearing protector fit testing, is. It's a procedure that's used to quantitatively measure the amount of noise reduction a specific hearing protector is providing a user. And this occurs across the wide spectrum of hearing protection that we have. It's not just for in-the-ear hearing protectors, but it can be used for over-the-ear hearing protectors. And we have a number of systems that are available to do this, as we'll demonstrate here later in this presentation. It measures a personal attenuation rating, so the amount of attenuation a user is going to, or a worker is going to achieve in using their selected hearing protection. And with this personal attenuation rating, it's specific to the individual ear and that particular hearing protector for that worker. We recognize this is a single number. It is a real world measurement, but it is a measurement that occurs at that place and time. But it is better than what we may achieve, for example, in a laboratory environment. So we'll go ahead and move on to the next slide as to why we should conduct this HPFT. So, of course, Dr. Merkley talked about the update to the IOHA update in January 2025, which recommends employers to use individual quantitative fit testing and achieving a personal attenuation rating, which is a change from their I almost said insistence, and that's not what I meant to say, but is a change from their previous recommendation and using a derating method. And that's, primarily because our technology has changed. So we are able to do this. And as you'll see from these systems that we show you, they're very portable, they're very easy to use. And so now that technology is much more available to employers and to those of us in the safety community, we can use a better method for ensuring that the hearing protective devices are working for our workers, as opposed to, say, an NRR. And then we have a few other reasons that we list here on the slide. Okay, there you go. So it does provide valuable training. So when you are implementing a program for HPFT, you can help the worker understand what right feels like. And of course, this is not always something that comes naturally to someone. Using a hearing protective device, while you may be a child of an audiologist or a safety professional, maybe you know how to use these, but otherwise, for those that are working in industry, we often just see where an employer may put these out, say, as you're entering a manufacturing floor, and there's some little foamies there, and they tell you, hey, you have to use these, and then someone just tries to stick it in, right? And they're complying with the requirement that their employers put out, but they're not actually using the hearing protector right. So we're ensuring that not only are they understanding what right feels like, but by doing that, we're also ensuring that they're properly fit. So if they're using the wrong hearing protection, then we can provide them with training on the right hearing protection for them, ensure that the employer is purchasing and providing the correct hearing protection for their needs, and then also allowing them to truly hear what that sounds like, because many people may not understand that they're not supposed to completely block out all of the noise. They're just supposed to get to a safe hearing level, and what safe hearing means versus what hazardous hearing hears and feels like. Next slide. And then, but what about the NRR, right? So I mentioned that just a little bit previously when I was talking about the NIOSH change in recommendation. So we still have an NRR that's listed, noise reduction rating, on each of the hearing protective devices. And I apologize, I know that this is a very US specific presentation because we are based in the United States. But there is a noise reduction rating that typically worldwide, depending upon the federal governing agency, there is a NRR that's assigned to hearing protective devices, or if you purchase them from the United States or a manufacturer in the United States, you'll see these. And this is a laboratory measurement, right? So it gives us in the dBz scale how many decibels of protection that we should be receiving from that hearing protector whenever a worker uses it. Now, NIOSH came back later and said we need to do, and NIOSH and other agencies have said we have to have a proposed derating method for the NRR because we know that laboratory measurements and actual field use are going to be different. So there's several derating methods. We showed two of them here on the screen, the NRR times 50% or the NRR minus 7 times 50% to estimate a level of protection for a given hearing protective device. But this still isn't the same as knowing exactly what the worker is achieving in attenuation. You know, if we compare this, for example, to respiratory fit testing, this would be similar to us just saying, let's say a worker is in a formaldehyde overexposed environment, and we just say, well, we know they need respiratory protection. We want to make sure that they have some sort of protection. So here's a half face or a half face piece respirator for you. And we help put them on, and then we send them into the environment. Now, is that going to be adequate? Absolutely not, right? We know that we need at least a full face respirator for that individual. We need the right filtration for that. In some cases, we may need supplied air, depending upon, I'm using formaldehyde, but in any sort of chemical environment, there may be instances where we need supplied air. And we need to be able to measure that that respiratory fit protection is actually providing the protection against whatever it is that we're using, and doing even a simple test to make sure that there's an adequate seal and that the person knows what that feels like. You can relate it to that model, right? So we're giving an individual, just as we would for a respiratory fit test, where we allow them to feel what right feels like when they're wearing their respirator. We're allowing them to feel what right feels like when they're wearing their hearing protective device. And we're ensuring now we have a quantitative measurement that says exactly how much attenuation they're receiving. So we have had several studies that have been performed over time using HPFT methods to show that the labeled NRR, again, just is not adequate in telling us how much attenuation the individual worker is achieving. So you'll see on the slide here, the yellow bar is indicating what is labeled on the hearing protective device. And you can see with the far left side, I'll go over that one in the interest of time. You can see they're all kind of following the same schematic there. But on the left side, that labeled NRR of about 29 decibels, right? And then as we go down to the 84th percentile of subjects, which in the 3 studies that were used to collect this data and provide this graph, we had, I shouldn't say we, I apologize, I did not do the studies, but the 3 studies that conducted this ranged from about 89 subjects to 533 subjects. So a very large sample size of workers across North America. And in this, we saw that for the 84th percentile of knowing that our measurements are correct, right? We are achieving about 14 dBs of protection versus 29 on the labeled NRR. Now, you may say, well, the derating method would get us to that level. If we had an NRR of 29, and then we subtract 7, we have 22, multiply that by 50%, we're now down to 11 dBs, and that's actually about right. So we're giving a good approximation, especially with that plus or minus 1 standard deviation. But then when we take it down to the 98% confidence level, we see that roll down foam earplug in real use in the field in a occupational setting is only providing about 4 decibels of protection. So of course, if you're a statistician, you know the 98th percentile, that's providing you with a very wide swath of people, and there's going to be many people up and down that spectrum. But that is a very concerning number, right? That we are going from what we're seeing real world, that we can say for certain about 4 dBs of protection versus what is labeled at 29 dBs of protection. And that same, we saw that same results across multiple types of hearing protective devices. So on this next slide, we're outlining exactly what NIOSH said in their recommendation in January of 2025. So this is a science policy update, and it basically replaces that old model of NRRD rating and saying that NIOSH is recommending hearing protector fit testing as an essential practice to ensure that HPDs, or hearing protection devices, are properly fit to each worker. So that is what is in the science policy update, and that will be the recommendation moving forward. So in our next slide, we do have another video. It's a video that we produced to help explain to, again, this is service member focus, as in United States military focus, but we also use it with our civilians that are in the Department of Defense to help explain what the target personal attenuation rating is. And so we will attempt to play this video, and hopefully we won't get the echo that we got last time.
Allie, will you mute your side?
Sure,
and
I
I'll
can
play it. I think that might be what was causing the mute, but here we go.
Fitting an earplug is like target shooting. It's a skill that takes time and practice to learn. When it comes to hearing protection, the target you're aiming for is the Target Personal Attenuation Rating, or Target PAR. PAR is a measurement of how well your hearing protection is blocking out hazardous noises. The target PAR is the amount of noise reduction from the hearing protector that will get you to a safe listening level. It usually ranges between 10 and 30 decibels, but really depends on how much noise you are exposed to. The louder the sound around you, the more protection you need. For example, if you're on the deck of an aircraft carrier, you need more protection and a higher PAR than if you're mowing the lawn. Hitting the target PAR is important. You don't want too much protection, or you can't hear important information in your environment. And if you have too little protection, hearing damage may occur. The sweet spot is a PAR that brings your exposure down to the safe listening level between 70 and 85 decibels. So, if you're working on a helicopter, we know the noise level is about 105 decibels. Your target PAR would be anywhere between 20 and 35 decibels, which gets your exposure into the 70 to 85 decibel range. Using a hearing protector fit test, we can accurately measure the amount of noise reduction you're getting from your earplugs. The goal of the test is to make sure hearing protectors provide enough protection, but not too much protection for your noise environment. Just like target shooting, if you miss your target, you need to try again. It might take a couple attempts of reinserting the earplugs and running the test before you hit the target PAR and find the perfect fit. Sometimes you might even have to try a new style of earplug to make sure you hit your target PAR. Once you find the perfect fit, you'll need to practice using the hearing protection so that you'll be sure to hit the target every single time. Bullseye. If you insert hearing protection the same way each time, you'll be adequately protected from hazardous noises. This will help prevent permanent hearing damage.
Okay, so I apologize. You're still having a little bit of an echo issue with that video as well, but the source link to that video is also provided in the chat. So, and you will have access to the slides after this presentation. So again, feel free to go to that link and watch the video again if you would like to use that with your personnel. We understand, again, it's a very US military centric video, but still accurately conveys what we need the worker to understand about a PAR, a target PAR. And so also a very simple way of showing this is our image there of a sound level meter, right? We've assessed their exposure to noise at 96 dBA, right? And the PAR, we're actually able to subtract a DBA measurement as opposed to DBZ and having to use a derating method. So whatever system you're using is going to give you a personal attenuation rating. So in this case, we have a 16 decibel personal attenuation rating, which then gives us 80 decibels effective protection sound pressure level at the ear. So in this case, for United States and DoD regulations of 85 dBA, 8-hour time weighted average, this worker would be adequately protected with that particular hearing protective device. Now, moving on to our next slide, that's exactly how you're using the PAR or the PAR, as we often call it. And so again, we're taking that protected exposure level, and it's equal to the actual exposure level minus the PAR. And we'll just go ahead and move on to the next slide in the interest of time here. And so a wonderful graphic to use is on our next slide. And this is able to, it shows us how to evaluate the appropriateness of fit. So you can use a lot of different ways of demonstrating this to a worker or to your colleagues for understanding the appropriateness of fit. But we find this graphic to work pretty well. So of course, if you're underprotected, and that's something that we focus on as safety and occupational hygiene professionals, we want to make sure that the worker is protected. So we often just make sure to give them that hearing protection. Sometimes our hearing protection programs are already ensuring that they have good hearing protection, that they're fitting it well. Unfortunately, we also know that being overprotected is a danger in the workplace because workers may not hear important sounds. So it is vital that we get to the appropriate level of fit, which is somewhere between 70 and 85 dBA, or based upon your country's or federal regulations in terms of what that upper limit is. Now, I believe it's 85 dBA as a recommendation worldwide, but somewhere between 70 and 85 dBA is that right appropriate level of protection. So what methods do we have to evaluate the PAR? We have 3 separate methods. We have the REAT, loudness balancing, and F-Meyer. REAT standing for real ear attenuation at threshold, and then F-Meyer stands for field microphone in real ear. So REAT, or real ear attenuation at threshold, and loudness balancing are both subjective methods of evaluating the individual's personal attenuation rating. And that means that they require user input when you are conducting the test. They do have about a 5 to 7 minute duration for each ear, and you can read some of the other information that's on the slide about these 2 types of tests. Dr. Merkley today has a REAT system that he can demonstrate for you, and I have an F-Meyer system, a field microphone in real ear, and this is an objective way of using a surrogate HPD or hearing protective device to make sure that there is no user input, which of course a lot of us like that, especially my undergraduate being in industrial engineering and working in human factors, knowing that sometimes human factors can get in the way of these test methods. It takes that out of it, other than the individual already having put the hearing protective device in. This works by having basically a microphone on the other side of the HPD, and then you have a microphone that will be on the outside. It presents a noise and then objectively tells you how much is being heard inside the ear and outside of the ear. So these 2 systems or these 3 systems all differ in how they accommodate the testing, and they also differ in how they expect the user to respond to the testing. And Dr. Merkley, is there anything else you'd like to add to that?
Nope, I think you explained that pretty well. I will say the reason we only have a REAT and an F-Meyer system to demonstrate is that the loudness balance system that has been developed is not supported anymore for software, and so it's if it was available earlier back when Windows 7 came out, but now it's the manufacturer doesn't support the software, so that particular system is not available.
Thank you. All right, so we'll go ahead and move forward a little bit because we would like to show you how these systems work, and I am cognizant of what time it is. It's I'm on Eastern time in the United States. It's 9:55. So what I'd like to do is I could talk a little bit about how loudness balancing works. So this method, we're not seeing this in use quite as much because, again, Dr. Merkley just explained that there's some issues with abandonware, so to speak. So the software is not being updated as well. It also does require the participant to match loudness signals in one ear to the other. So it's a little bit more difficult for the participant than some of the other systems that we can use, like the REIT system or an F-Meyer system, because they have to match loudness signals in one ear to the other. And many workers aren't used to that. They're used to being presented with some sort of tone, especially in audiometry. They get that pure tone typically in an audio booth. So they recognize receiving a tone and kind of telling you whether it's loud or soft and being able to give you that type of measurement. And so the other two systems do that a little bit more closely to audiometry than what loudness balancing would do. Right, and then Dr. Merkley has our REIT system. So I'll go ahead and mute my microphone.
I'm going to stop. I'll stop sharing. Well, hold on. I'm going to stop sharing this screen, and I'm going to bring up a REIT system that is currently available to use within the DoD. This is the Michael and Associates, the Fit Check Solo. So let me end that. So how the Fit Check Solo system works is like Ali was saying, it's a real ear attenuation at threshold. So it's like taking a hearing test. And let me share my. So you should be seeing the Fit Check Solo software. So it's like taking a hearing test, but in this case, the user will determine the loudness, the very softest point they can hear without a hearing protector, and then they'll insert a hearing protector and then go through the same process and identify the softest sound that they can hear through the hearing protector. And then the system takes the difference between the unoccluded and the occluded response and calculates your personal attenuation rating. And I see in the chat there was a question about, how do you know what's an appropriate PAR unless you know the individual's exposure? And you would need to know what their exposure is in order to determine an appropriate PAR. There are systems out there that will, set, like, say, a 20 decibel PAR. And if you think 20 decibel is adequate, then you just like the NIOSH developed a system that the user would adjust the volume on their computer or whatever device they were using to test their attenuation of their hearing protector, and they would adjust the volume to the lowest volume that they could hear, put their earplugs in, and then go to another sound that was 20 decibel above or 20 decibel louder than the unoccluded or the original response. And so you'd play that tone, and if you could hear the tone, then you knew you weren't getting at least 20 decibel of attenuation. If you didn't hear it, then you knew you were getting at least 20 decibel of attenuation. So those are kind of pass-fail type systems. But this system, we're going to go into a new subject. Let me just put in test. Okay, let's go to a new fit Okay, hold on. I have to put in the last name here. So here's our new subject, and we're going to put the headphones on, and then you should be able to hear the tone. So we'll run an unoccluded and then an occluded response. And you can see in the software there we're on the unoccluded response. Now, how the individual does the test, they use the mouse and will present the tone, and they use the mouse to scroll down until they can't hear the tone. So I'll put my headset on. Helps to put them on the correct ear. And we'll start the test. You should be hearing the tone. And we're just going to lower that tone until we can't hear it. Mark it. Again. So it runs 3 runs for each frequency. And we're going to run a 3 frequency test. And I'm just scrolling down until I can't hear the tone. You should be hearing. So that completes the unoccluded test. So now the individual is going to take their earplugs and roll them down, get them good and fitted. And now there are a couple of different methods. Some research studies have had an examiner explain exactly how to fit the earplug before the individual fits it. We are having individuals fit their own earplugs the way they would usually fit them first. So we'll go ahead and put that in and let it expand. I'm not going to let it expand for a whole minute, and I'll give it a few seconds, and then we'll run the test. Okay, so I'm going to let that expand for a minute. So I've got both my earplugs in. We'll put the headset back on, and now we're going to run the occluded test. So we just go up and select the occluded test, and it's going to give us instructions. So you can give instructions to your patient. We'll dismiss that and we'll run the test. Again, I'm just lowering the volume until I just barely hear it. Okay, now I'm done. We'll take the earplugs out and we can look at the PAR report. Now I'm going to bring this over. You should be seeing now the PAR report from this. So it's telling me that I passed, but what I'm really looking for is what is my PAR. So the PAR is 26 decibel. I think the noise reduction rating on these earplugs is around 30 to 33 decibel. So I'm relatively close, but that allows me to know that if I'm exposed, you know, if I'm, well, it tells me on the report, my maximum exposure is 111 dBA time weighted average. So if I'm below that, then I'm good. Now, again, like Ali mentioned, we want to be sure that we're not overprotecting an individual too. So we want that PAR to bring our exposures down to that 70 to 85 decibel range. All right, Ali, I'll turn the time over to you. You can demonstrate the FMIRE.
Great, thank you so much. And I know we've had some questions in the chat. We will be sure to answer those at the end. I did put a little bit into the chat already, just because someone asked a question about how would an individual. You mentioned that already. You said that question, Dr. Merkley, but there are some tools out there. So if you don't have access to noise dosimetry or area noise sampling in your work environment, you can look up what the general standard would be for the types of equipment that your workers are using in their environment to help guide what the PAR should be for that particular worker. Of course, we would not want to rely on that solely, but we also understand that there are resources constrained in many environments. And so if you don't have access to data such as that, it's still better to use an estimated level of exposure for the type of equipment they're using, and then create a PAR off of that than to have nothing at all. And so now I'm going to be demonstrating the 3M EarFit, which is an FMIRE system, field microphone and real ear. Again, this is a objective system, so I'm going to be the tester and the testee today, right? I don't have to provide any feedback like Dr. Merkley had to provide feedback in terms of letting it know exactly when he could stop hearing the signal that was presented. I will give you a heads up that when we run this test, it gets loud for about 5 seconds. All right, so it's a very quick test once you get everything set up. And so before I share my screen to show you what the software looks like, I just want to show you kind of what the system looks like. So these are our 2 microphones, and these are going to be attached to a surrogate hearing protector. Here I have just a simple foam hearing protector. And on the back of this, you can see how it is set up. And I know this is a little bit dark, so I apologize for that. But there's simply only a power cable, the connection to the microphones, and then the connection to the computer. So pretty simple setup here. And then it's attached to a small stand. And you want this to be positioned in a way so that it's at the worker's listening level. So if they're sitting down, that this is presented to them basically right in their face, so to speak. And we're looking at for this manufacturer in particular, for a 16-inch, and I know I'm using imperial units here, so I apologize. I don't know what the centimeters are on that, but a 16-inch length. But you don't necessarily need to know other units because the manufacturer provides that. It comes to this Y junction in the cord. And if you go from there to where the worker is seated, then you are at the right level for this particular device. So now I'll go ahead and share my screen so you can see what the software looks like. And hopefully that is okay. If I could get a thumbs up as to whether or not that's...
Yeah, that's good.
Great, thank you. So you can see here, very similar to other systems, you need to enter some summary data at the beginning of this. And so you'll have, there are a choice of multiple languages The operator is myself, and I've already selected my company here, but you can easily add these or you can edit operators as you go through. And then we're going to begin testing. Now, the very first test of the day, or the very first time that you're using this, you're going to have to place the microphones on a hook that's here in front of the speaker so that you can conduct a daily check. Now, I don't think, yeah, for some reason it's cutting off the very bottom of my screen. It will also indicate whether or not this particular system has been calibrated by the manufacturer or your calibration company. And so it would give you an X or another symbol. This one is for training use only. So if you do happen to be able to see that and you see that it's not calibrated at the bottom of the screen, please understand we're using this for training purposes. Its last calibration was in 2021, so it's technically not calibrated. So we're going to click begin testing, and it's going to complete that microphone verification. I'm going to turn my speaker away from you, so maybe I'm not blasting the speaker on my computer too much, but it's not too loud for the verification part. Right? Very simple, and we go ahead and show that the verification passed, so we know that the microphones are picking up what they should be picking up. One thing we didn't really mention, I know, again, we are a little bit pressed for time here, but each of these systems have their own ambient noise level called a maximum permissible ambient noise level. That's allowed in the room that you're doing this in. So some question that we often get is, you have to complete this in a booth, because that would be a very limiting factor for those that are on a occupational work site trying to conduct this type of testing. And the answer is no. You just need a quiet room. All right, so we need a quiet room, and each of the manufacturers have a different permissible ambient noise level. Right now, manufacturers would like us to use type 1 sound level meters, which are difficult to get. So there is, you can still use a type 2 sound level meter, and there is some campaigning, so to speak, to ensure that type 2 sound level meters are allowed for that measurement. So I apologize for that brief aside on that. I just wanted to mention that. So we're going to continue to testing. And then here you're going to select an employee. Now I'm selecting not Allie, not Reed. That's just someone that I've already put into the system. And you can see I have a test history that where my PAR has not been very good so far. So we're gonna try this now. If this was an actual worker and we were getting these PARs and this worker is exposed, and I'll go ahead and show that piece of it, because you do have to input a noise exposure level for the worker. So in this case, I'm going to say that this worker's using a chainsaw, right? So that's about 100 decibels, 110 decibels. And right now you can see that it's actually set to the 3M Peltor earmuffs. So that's one of the limitations of the system. You have to have 3M products, but you can come into the system and then select which ones you're actually using, which in this case, we are using the 3M Earsoft Yellow Neons. And I do not, unfortunately, have the over-the-ear hearing protection to demonstrate today, but they do have surrogate over-the-ear hearing protection devices. And so if that is something that your company needs, you can also get that from the 3M system. And so in this case, before we hit run test, we have to make sure that the hearing protection is fitted to the worker. And then we're going to use these microphones to clip it either to a set of, to the worker's eye pro, so to speak, their eye protection, if they don't wear glasses. And if they're like me and wear glasses, then they're able to fit it to their own glasses that they're wearing. And I will tell you, when I was practicing with this system, I was having some ear pain. So that's something that you do want to ask your worker as you are attempting to fit them. And so that's why my PAR was a little bit low, because I actually was having ear pain and having difficulty in inserting the hearing protection appropriately. So like many other systems in audiology, red is right, right is red. So for my right ear, and I apologize if this looks backwards because I'm on a camera, I'm going to insert the part that will measure my inner ear, or the amount of sound that's hitting the tympanic membrane, the eardrum. And then I'm going to hang it onto my onto my glasses so that it is in a parallel with my face and it can receive the sound signal. I'm going to do that here on the other side. Now, of course, when you're doing this on someone else, it becomes, in some ways, it's a little bit easier because you're not having to feel it like I'm doing right now. But you also want to make sure that you're not tugging too hardly or with too much strength, so that you do not mess up their test. Now I'm going to ensure that I am standing about 16 inches. I'll lower myself here because I'm actually standing. Okay, so I'm about 16, my ears are about 16 inches from this speaker. Now this sound is a lot louder, but again, it's about 5 seconds. You should be able to hear it on the microphone, but hopefully it's not too loud. And that's how quick it is, right? So it immediately goes to a very quick signal. Now it's telling me that I only have a 5 dB par, and that's primarily because I can tell right now that the foam hearing protection has not completely expanded in my ears. And again, interest of time, we're not doing not allowing for that 1 to 2 minutes to allow the foam hearing protection to completely expand. But if you were to receive a result like this, obviously this would tell you we need to use a different hearing protector, or we need to at least try to refit the hearing protector to the individual. And so the great thing about this system is that it does give you a number of different reports. So I've already reported that I have 110 decibels of exposure in my work environment. It will give you that quick view where my left ear was it's expanded a little bit more than my right ear. And I will tell you the right ear is the one that's having some pain. And I'm here. So it's giving you an overall safety guide. I'm exposed to 105 decibels, and with 5 dBs of protection, I'm only at 100 decibels, right? So that's not helping very much. Or excuse me, I'm exposed to 110. It's only bringing me down to 105. That is insufficient. You can see what the attenuation is at each level. So at the 8,000 level, it was okay. But then as you come up to the lower frequencies here on the left-hand side, I was not receiving really any attenuation at all. And then it does provide a detail view, so it gives you an error amount. So up to 13 decibels in the left, up to 10 in the right. Now it's very quick to retest the product. So I'm making sure that this is all set up a little bit. It has expanded a little bit more. I can tell I'm not getting the full force of this hearing protection, but we can try it again. And I heard some people say that it was an incredibly quick sound, right? So I hope this is not too loud. I'm gonna see if my sound is, okay, we're doing noise suppression. So I'm gonna take the noise suppression off. So I apologize in advance if this is very loud. Hopefully you can hear it this time though. But as soon as you click retest product, be prepared to retest the product, right? So it's going to go immediately to that very quick sound. It doesn't give you a warning before you do the retesting, which is great in terms of getting through the test quickly, but can be a little bit of a shock for the first couple of times that you use it. So I'm going to retest the product, and this time, of course, I'm not doing this correctly. I'm not sitting in front of it, but I want you all to be able to hear the sound. Hopefully you all were able to hear that. So if not, it was a very quick sound. I did take noise suppression off of my team, so I hope it worked a little bit. But in this case, again, if this was the same result that I got with the same hearing protection, if I refitted it during that time, then I'm going to want to try to find another hearing protector because it's obviously not working for me. Or it could be that, again, as I reported a little bit of ear pain, maybe that's what's going on and I need to talk to an audiologist or another occupational health medical professional to ensure that that worker can be fit at that time. And so I will go ahead and stop sharing this screen. And then we can go back to the slides.
I'm going to go back. I just real quick, because I know we're about out of time. And I want to leave some time for questions. So I'm going to move through these demonstrations. So anybody can conduct fit testing. It doesn't have to be a medical professional. And the, how do you learn about how to do fit testing? Well, the Council for Accreditation in Occupational Hearing Conservation is developing training for individuals that will conduct fit testing. And it will be launched likely probably June, July of this year. In fact, we are going to be working with the IOHA group at the World Fair, and Dr. Amir Wolf will be talking about hearing protector fit testing at the World Fair Occupational Safety and Health Week. So we're looking forward to that. But there is some training. It includes knowledge checks and a final exam. And once an individual goes through that training, then they understand the process of doing fit testing. And we recommend that they then get with a professional to work on what the specific equipment that they have in their workplace. So you should be able to understand all these things. And there are references. I got some questions about different studies. And so you can look at different studies for hearing protector fit testing in the workplace. So we'll open it up now to questions. I'll stop sharing this and get back to you, Matthew.
Excellent, beautiful. Thank you so much. I think it's been a really engaging an hour plus with you guys. Thank you so much. I think for all occupational hygienists on the call, I believe we can all connect with this. What we do as occupational hygienists, we want to make sure controls are in place and they are effective. So this element of fit testing is what really test our ability or capability as industrial hygienists or occupational hygienists, because we can go ahead, do all the sampling, all the monitoring, but if controls are not effective, I don't think we've achieved our objective. So thank you very much, John and Ali, for throwing some lights on this and how we can connect to that end that helps verify that controls are effective. We have a few questions, right? And I think maybe if you can switch over, I don't want to read the questions, maybe allow you read them yourself. So I try to move all the questions that were put in the chat into the question and answer box. So if you can take the questions in the order in which you see them, that will be great. Can you see them?
I'm opening up. I've never used this box. So first one from Matthew. So these are all from you. So
I just moved them, the ones you see names. Yeah. So go ahead. Not from me.
Yeah. If the PAR achieved results in the final noise exposure that is below. Okay.
I think you answered that, but you can say that again. Yeah.
If you get below 70 decibel, that's not necessarily a failure. It just means the individual worker is potentially overprotected. And that can lead to communication problems, difficulty hearing alarms in the workplace. So you need to look at the worker and see, what are the risks of them being overprotected. If the risks are high, then you'll want to find something different. Next question: do all hearing protection manufacturers make plugs? No. The 3M system, it can only be used with a 3M surrogate earplug. So if you're only using a 3M product, then the EarFit may work for you. If not, then you'll want to select a product or a testing system that allows for other other manufactured hearing protectors. Is there any F-Meyer unit available in the market aside from 3M? There was one that Phonak had developed. Phonak is a hearing aid manufacturing company. It's a brand name worldwide, and they had a hearing protector. It was a custom hearing protection device, but that system only worked with the Phonak product. So there are not any F-Meyer systems that I'm familiar with outside of the 3M system that are available on the market. There are multiple REIT type testing systems. The one we showed was the FitCheck Solo. There's an audiometer called the Watts, the IntegraFit. There are some even in the UK. I don't remember the names of them right off the top of my head, but there are a lot of different REIT type systems that are out there. So are there any problems with using REIT for individuals with existing hearing loss? Yes. It depends on the amount of hearing loss that they have, because they may not be able to, it may affect the PAR and reduce it because the difference between their the amount of noise that the system can produce may be too soft for them to hear. So it can affect the results, your PAR results. It also depends on where the hearing loss is. It does test multiple frequencies. So if they have a super high frequency hearing loss at 6,000 to 8,000 hertz hearing loss, then it probably won't affect the test. But if their hearing loss is in the, well, above 2,000 hertz, then if it's above 2,000 hertz, then it probably won't affect the test. If they have hearing loss in that 500 to 2,000 hertz range, then it can affect the test, yes. Are we only checking 2, 3, and 4,000 hertz? No, so I answered a question that was in the chat. You know, why test only 1 frequency or 7 frequencies? You can, with most of the REIT systems, select which frequencies you want to test. If you test 7 frequencies, you'll get the most accurate PAR. But one of the studies that our Navy Submarine Research Lab did was they looked at testing 1, 3, 5, and 7, I believe it was, frequencies. So what they found was that testing 3 frequencies, the 500, 1,000, and 2,000 hertz, didn't yield a statistically significantly different PAR than testing 5 or 7 frequencies, but the test time was significantly reduced. So we're recommending in the Department of Defense, and the Department of Defense in the United States is requiring fit testing now on specific individuals that are at risk for hearing injury. And so we're requiring them to at least test 5, 1, and 2. Okay, not 2, 3, and 4. 5, 1, and 2 would be the 3 frequency PAR that we would recommend. If you're only going to test 1 frequency, the lower frequency would be the one to test 500 hertz. But again, you're not going to get the most accurate PAR by only testing 1 frequency. Next question was, can you not simply perform a manual hearing test without? No, it's so the method, the calculation for determining PAR is more than just taking you know, a pure tone measured unoccluded response and then, you know, whatever the occluded response is. There's a mathematical algorithm that's specified in the ANSI standard on hearing protector fit testing. There's a margin of error that you have to incorporate. So it's not as simple as just, you know, doing a test without and then doing a test with and averaging those numbers. So this is by Ronald. I'm sorry, Ali, if you want to answer, I'm answering these questions. You want to take this next one?
Sure. Well, I reopened the Q&A and saw there were some new ones, so that's why I ran off screen for a second. So one person asked if you could test muffs with the F-Meyer system. So as long with this particular one, again, it's manufacturer specific. So for 3M, they produce Peltor ear muffs. Now, I don't have Peltor ear muffs with me right now, but yes, you can. Short answer to that. Basically, what it is you'll get a surrogate HPD. We'll pretend like this is that. And it would still have that outlet, if you can kind of see that in the video. It would still have that outlet so that you could plug these microphones into it. So yes, you can test muffs with the F-Meyer system as long as you have the surrogate hearing protector. You purchased that as part of the system, and you're using the 3M muffs at your workplace. In terms of sharing links to the different fit test systems, I mean, we don't have that as part of our presentation because we're not, I guess, necessarily saying all of the manufacturers. I know within our group we have been evaluating different manufacturers in terms of what we can purchase within the Department of Defense for the U.S. military, but we don't have a list of links that I know of to each of the manufacturers.
Yeah, I think if you go onto Google and Google F-Meyer hearing protector fit testing or REIT, you'll get a list of potential manufacturers.
And then let's see. So we already answered the question about how an individual would know what is considered a passing par without knowing the exact level of noise. Like I said, I put that in the chat, and you can use many different again, Google is our friend on this one. You can use a lot of different sources to show different machinery or whatever they may be exposed to in their work environment to give you an estimate to get if you don't have the direct sampling measurements from an occupational hygienist, then you can use that to estimate what par you're trying to get to. And it's still going to be a better measurement than attempting to use an NRR or a derated NRR. So let's see.
So Ali and John, I think we still have a few, maybe 2 or 3 more questions, but just to respect the all our guests, I would like to wrap up, but maybe we'll take like 10 more minutes afterwards for people that are open to, have more conversations, right? So I think it's been a very beautiful session with you guys. Thank you so much to Andrew and Alison. Thank you for all the engagement. And I also want to thank all the participants for joining at this time. When you join webinars like this, it's a great demonstration of your commitment to learning, continuous professional development, and as well sharing knowledge and best practices. Some people are here just to listen and also share their own perspective, which is great. So thank you very much, everyone. So before I let you go, just a quick reminder. Let me see. Can you see my screen? There is Expo 2025 this year, and health and safety professionals are gathering in Osaka, Japan, between July 16 and 19, where we're going to have days dedicated to safety, health, and well-being. Please, if you are open, we're kind of encouraging everyone to be part of this conversation, and let's talk about how we make safety, health, and well-being priority in nations, in employers' approach to work, so that people can, have a healthy life. So please sign up for this if you have not, and if you are opportune to sign up. We're encouraging this for everyone this year. Thank you very much again to our great speakers, Dr. Andy and Alison. Thank you very much, all our attendees as well. And that brings us to the end of our webinar for the second one this year. Look out for more webinars. We're going to be posting on LinkedIn and all our communication channels, and you're all welcome to join and spread the word as well. The more we have opportunities like this to collaborate and learn, the better for our world. For the members of IOHA, I'm sure you would have access to the videos and the recording from this session. And I'm sure Dr. Andy And Alison, they're open to more questions and more engagement even after now. Thank you very much, everyone. And we can go back to the questions now, except Dr. Andy and Alison, if you want to say anything at this time, that'll be great. Otherwise, we'll just take 10 more minutes to answer the rest of the questions. Thank you.
All right. Thanks for the invitation.
Yes, thank you very much for having us today. And I see there are some questions in the Q&A and then also in the chat.
Yeah. There's one about the WHT hearing test system.
The Watts.
Yeah.
I didn't see the question about the Watts.
It says, have you heard of the Watts hearing test system? They offer HPR. So
I have a Watts system. I have a Watts system sitting here in my room. Yeah, I've heard of it. It's a great system. It is an audiometer as well as a hearing protector fit testing system, and it uses the REAP method that we showed. And one thing, the Watts does just binaural testing. It does not do single ear. So it will test both ears at the same time. And the PAR that's given from the Watts system generally reflects the fit of the poorest fit ear.
Mm.
So, but yeah, it's a good system.
And it is, I think, one of the more utilized systems in the Department of Defense right now because of the dual capability as well with boothless audiometry. We had 2 hours in our presentation yesterday, so we actually did show that one on screen. It's a little bit, since we had the ability to share the software too, we wanted to be able to show you that today.
Right.
I think there's maybe one more.
So there were some questions a while ago. Let me take one. How can we take lack of fit testing into account when selecting hearing protection and sufficient PAR levels when real world testing show very reduced efficacy compared to the NRR and the SNR? I'm not sure I understand.
So and perhaps I apologize if I didn't, if I wasn't clear on that slide. So what that slide was showing were actually a compilation of 3 different studies where they conducted HPFT, so in a real world environment, and compared that to the laboratory NRR. So we were showing efficacy of the NRR not being as high as what we were actually experiencing using hearing protection fit testing system, HPFT systems. So again, I apologize if that explanation was seemed a little bit backwards there, but what we saw was that we were not achieving sufficient PAR in comparison to what the manufacturer was telling us we should be receiving with the listed NRR. If I'm understanding.
So our Occupational Safety and Health Administration, they require employers to use the NRR to determine if a hearing protector provides sufficient protection for the exposures in the workplace. Mm-hmm. And at the International Hearing Protector Fit Testing Symposium that was done this was in August of 23, OHA came out and said they still require manufacturers to use that method, but recommend that they only use that method to determine if the hearing protector is adequate for the work environment, but then recommended hearing protector fit testing to ensure the employee is getting as much protection as they need. Because we just fitting somebody because the NRR says they should be protected is not a guarantee that they will get as much protection as the NRR says. And
the individual did come back in the chat and said, and So in cases where fit testing is not possible, should we overestimate the SNR/NR used? You can still use the derating method. That's still an acceptable method for estimating the level of protection that the individual is getting. It's just that best practice is now, as Dr. Merkley just said, to use HPFT in the workplace. So if you don't have an HPFT system right now, you should still use a derating method as we showed earlier in the presentation. But if you don't necessarily have to derate it further than that, it's just that HPFT is going to provide you the individual's actual attenuation rating.
And then Carl asked, how would we address hearing protection that is part of a communication device? Now you should evaluate the protectiveness of the system outside of the communication. So if it's a noise muff, then you'll want to measure the protectiveness of the noise muff, which may be difficult if it's not a 3M product and you can't do read, because there aren't very many systems out there that evaluate noise muffs. But if it's an ear plug or an ear level type system, then you could use the read method or loudness balancing. And you're just evaluating the system, not the communication, the electronics of the device.
And I did see, I scrolled up a little bit in the chat and I saw one that as an industrial occupational hygienist that I thought was interesting. So do you need to perform a testing for each worker individually, although several workers have the same noise exposure? And yes, so, and the reason for this is that this is considered basically an individual measure. So although they may all be exposed, let's say we're in a large manufacturing setting, lots of machines, we did our area noise sampling, everybody's exposed to 95 decibels. We don't know that each worker is putting their hearing protection in correctly or that they have the right size or the right protection for them. So we need to conduct HPFT for each worker despite having the same exposure as all the workers in the same environment.
That kind of gets to your respirator fit testing as well. You wouldn't just fit one individual and say, oh, well, they're getting protected, so everybody use the same respirator.
Yeah, I think maybe just one last one on peak exposure, if you look at the Q&A.
On peak?
Yeah, current standards.
If the PAR achieved results, is that the one? If
No,
the PAR?
No, the very last one now, just posted. It's some peak noise.
I have a question on peak noise. Current standards were established at times when it was difficult to assess the real peak. The averaging is too long. How does this translate into inadequate hearing protection?
So we're talking about, that impulsive type noise.
Yeah.
Is that what none of the systems really evaluate peak insertion loss. They're all geared toward the dBA measured. But I will say, so if you have a lot of peak or impulsive or exposure to a lot of impulsive noise and not so much steady state, I would still conduct the test based on their overall exposure, whatever dosimetry readings that you have, and then educate the employee about signs and symptoms of hearing impairment. Now, we in the DoD, we have standards for single hearing protection, even for impulsive noise. If your impulsive noises are less than, I think it's 156 decibel, then single hearing protection should be adequate. If it's above 156 up to
180.
I think 165 dB peak, I'd have to go back and look at the regulation. Then double hearing protection is required, and anything greater than that, it actually requires approval from supervisors. But we have weapon systems that generate 190 decibel peak pressure, and they're very, very loud. And we restrict the number of rounds that can be fired from those particular weapon systems based on hearing protection, and then also other, because that much noise is going to cause other types of problems in the body. Almost any air-filled cavity is going to be affected by that kind of an impulsive noise.
And just a little add-on to that too. There is a lot of research right now that is emerging into making dosimeters that can achieve actual results and gathering that peak noise consideration. So as we know, a typical commercial dosimeter is going to top out at 140 dBp, and we may see it go up to like 143 or 145, and that's really just kind of a software glitch, so to speak. It can't go above that. But there are some dosimeters in research right now, and there was a presentation on this at a recent conference that we attended, that are going above that level. So it's coming. I believe that the capabilities are coming, but we're just not quite there yet, and being able to fully establish those noise levels and then also use it with our HPFT systems.
Great. I think we need to make a stop here now. It's 15 plus minutes over but I'd like to say thank you again to Dr. John and Ali. Great job, guys. It was really engaging. We had over 160 folks at the time, and even 15 minutes after, we still have over 58 plus on the call. So it's really been a great session. Thank you very much to you both, and thanks to all the participants. Until the next webinar, thank you very much.
All right. See you later.
Thank you.
See you later.